I'm recording now.
Yeah. I was going over the Simtech website last night a bit, and I noticed that we can even take a SolidWorks drawing of a cabinet and nest it out and do all that. I'm not saying that the wood CAD/CAM isn't better for that, but potentially that could be done as well, correct? I mean, it shows it right on the website.
I mean, anything you draw in SolidWorks, any kind of components in SolidWorks.
Uh-huh.
Well, also AutoCAD too. AutoCAD too.
Right, or Inventor, regular AutoCAD, 2D drawings, 3D drawings. It's a CAM program that has nesting capabilities and advanced nesting capabilities. Things like tool stay down, common line, two-sided nesting. These are all the advanced features that can save cycle time at the router.
So I think that the wood CAD/CAM has a boatload more to offer, and that's probably what we need actually. But you can certainly do the nesting and the program writing for cabinets as well. So, pero este programa de router sim no es únicamente para sillas. Tú puedes los dibujos, los gabinetes y cualquier cosa pueden hacer las explosiones. Este programa de router sim es el programa para usar en conjunto con SolidWorks para hacer todo lo de CAM. Pero el otro programa de wood CAD/CAM es bastante más amplio. So, estamos hablando de dos programas. Router sim es un nesting, nada más. Nesting. Pero es muy bueno, es usado por muchas compañías, bastantes compañías. Es para SolidWorks con router sim es una buena terminación. Es mucho más económico también. Okay. Y wood CAD/CAM es completa. Es dibujando y programación y donde está tu trabajo en la planta y todo eso. Okay. So I would say, vamos a empezar. Okay, now you're showing me the chair on the screen. Are any of those parts listed as solid wood?
As they drew it in SolidWorks, they have not specified any specific material. So what they did is they applied an appearance that looks like wood, but they did not attach a material. For example, if you attach this to a material called steel, then you get the mass properties of steel, and you can find out how much this weighs. You could put it in as pine or plywood, and of course the weight would change because the material has engineering properties like a density.
And all those engineering properties are somewhere in router sim?
They are part of the materials. That's all part of SolidWorks. SolidWorks can have a material, and then that material is also passed to router sim, and then we use that for a sheet size. You know, like the material to us is what size to nest on.
I got you. Aparentemente SolidWorks tú puedes especificar los materiales y no hay especificaciones en esto. Es algo medio importante. Well, I would see. Well, okay, let's just go ahead and begin, I guess.
Okay.
Porque no viene.
The model that you've drawn has part names.
Quick question: You're going to be recording this, right?
It's recording now.
Okay, go ahead.
So in SolidWorks, you give your parts a name. Every part has a name in SolidWorks, and they can have a material. And we capture all of that using our automatic feature recognition called SolidSim.
Mm-hmm.
And I have settings here that have a way to ignore certain things, like if there are nuts and bolts and screws, and there are in this model, we would ignore anything smaller than, say, 101 millimeters square. That's a way to get rid of dowels and screws and hinges and pins and nuts and bolts. Okay, it's going to ignore those. You can also specify a minimum and maximum thickness so that if you have a huge assembly, you can just pull out the half-inch material out of a job. See, by setting a minimum and maximum thickness, it'll be able to pull out just a certain thickness of material. It's just a few clicks to make the toolpaths for this. Does that give an explanation enough, or did you want to let them know any of that? We're going to get the part name and the material from SolidWorks.
Pero esos son los nombres de partes llegó de SolidWorks. Y no llegó materiales, que ellos piensan es mejor poner materiales en SolidWorks, importar los materiales porque los materiales tienen características. Y también tú puedes hacer filtros. También puedes poner medidas pequeñas y grandes para bloquecitos, tal vez van a hacerlos en volumen y no van a hacerlo como parte de medida. Okay, go ahead.
So I changed one part to maple, so we'll see it come out in maple. I picked the button, and here's where it does the automatic feature recognition. And so drill holes will become circles with a depth of cut. Dados become a rectangle with a depth of cut. All of that is happening now automatically in this feature recognition process. This is automatic feature recognition, and it will turn each one of those parts. There was 48 parts in SolidWorks. Some of them had quantity 2 or 3, and it's converting those into individual drawings so that we can make the toolpaths for each one of them.
Well, let me explain that. And Moses Markovich just came in. He's the director of the plant here. So,
all right.
So, este sí es de nuestro CIA, es 48 partes. Ahorita, con el dibujo hecho, él tienes que tocar un botón y ahorita está reconociendo todas las partes y dibujando. Right now, it's basically drawing each individual part and
right, it's doing the automatic feature recognition, and here it creates the cut list for us. Right here is the cut list.
So that's happening as we speak. It takes a couple
minutes. Yes, it just finished, and here's the CSV file. CSV is another name for comma separated values. It's also an Excel spreadsheet. You see how it has an Excel file? All right, so I create the CSV file. That is the cut list.
How long did that take to do the character recognition on that chair?
Less than a minute. A minute to do the feature recognition, and here are the parts. And I have the names from SolidWorks, the maple, and there's that one we put in maple.
Bueno, entonces.
And there are the panel dimensions for the saw.
This is the list of the parts.
Yes. See, there was a total of 34 unique parts. Some of them had quantity 2. See that? There's name, material, quantity. So there was 5 of these, 3 of those, 3 of those. So if the fellow that drew this was there, he might remember drawing 5 of those things or copying it 3 times, copying this one twice.
This is for one chair, right?
It is.
Can you change that quantity and do the character recognition for like 23 chairs?
Of course, yes, we for as many as you want.
Alan just came in and he's in charge of the chair plant. So if it's possible to go back to the picture of that chair, do the character recognition for 23 chairs, that would be great.
All right, sure. Here's let me erase the folder so we'll just start it from scratch here. I'm going to delete the folder so it's just from scratch. Here's the SolidWorks model, and I took and put one of the parts on maple. Okay, you can give it the material name. It's this part right here is going to be made out of maple.
En nuestro dibujo, los partes no están identificados por materiales, pero tenemos que identificarlos como triply, maple duro, o cualquiera. Pero no están identificados en Kinetica. This is SolidWorks, right?
This is SolidWorks, right. I'm in SolidWorks. you sent me this model, and I have some.
What part did you change to maple?
I changed this part here to maple.
This one?
And, yep, the blue one right there, and I changed this one to maple.
Él cambió esas dos partes de maple, so they will, es para ver cómo lo maneja. Okay, go ahead. How many chairs are we going to make?
Well, here's the button to do the feature recognition. I got my Solid Sim Connect button. I pick that, and it does the feature recognition. So if you wanted to do a stopwatch here, I'm at, my clock says 117. It'll probably be done processing this by around 118 or 119. So it's doing the feature recognition process right now. This is automated. My hands are off the mouse. They're not on the keyboard. It's going through.
El programa está separando el mueble y dibujando cada parte más o menos, con pernos y todo eso. Me está exportando de un storyboard así, pero por pieza, no por ensamble. Sí, Sketch es el programa. Sí.
There's the model. Now it does the feature recognition. Now this is the part right here that saves the most amount of time. For you to take a SolidWorks part, just one part, and turn it into something you can cut, might take you 4 or 5 minutes for each individual part. And then you don't know the depth of the drill holes, you don't know the depth of the dados, you don't know the material it was on. So this step right here that's taken exactly 1 minute, okay, there it is, the clock changed to 118. It makes the CSV file, and it gives me a whole folder full of drawings. There's the parts.
Show the parts. Show the parts, Kenny.
So in other words, en otras palabras, en un minuto el dibujo convirtió a todas las partes y mucho otro data. Mucho otro data. Y los partes tienen especificados los pernos, profundidad los pernos. Y por fin quieres hacerlos en máquinas manuales, okay, pero la idea es, this is the list of parts?
It is. This is the cut. This is the master cut list that has the name of the parts, which are from SolidWorks. The guy that drew this in SolidWorks gave it those names. These are the materials from SolidWorks, including 2 parts that are on maple material now.
Okay.
And here is the quantity of those parts. So there's 5 of this first part right here. That means in SolidWorks he copied it 5 times.
Okay, no. So
right?
what's the...
Now, this makes 1 chair. Now, when I run it to manufacture it, I could tell it I need 23 of them.
This is para un espía. Los partes, el tamaño de pieza, medidas, pero ahorita puede cambiar de 23.
And here are your panel dimensions. These are the panel dimensions if you want to cut them on a saw. There's X, Y, Z. If you want to cut them on a saw, CutRight can import column F for length, G for width, and H for depth. Those are the saw. That's for the saw right there.
This is en una sierra. Y no estamos haciendo esta. Pueden importar esta información y hacer las optimizaciones por la sierra y lo envía directo. Hecho. Nada más aprenden la sierra, saben la lista de cuántos tableros lo necesitan y meten el 4x8 primero y it's done. In this momento, it's okay, go ahead.
All right, and so that is the cut list. That's called an Excel file. It's a CSV file. Now, I can start manufacturing right now with 1 more click and say cut with RouterSim. Okay. So I can complete processing 1 chair with just 1 more click. But you told me you want 23, so I'm going to do a couple extra steps here. All right. First thing I want to do is show you the results are sitting here in CAD with part numbers on them. You can see the part numbers on both sides of the parts, right? They're all on there. There's a really cool feature that's built in to do what we call an exploded view. So this lets you move your mouse and do an exploded view, which is handy for assembly, right? You could show your guys how to assemble the parts this way. You can take pictures of this, save it as PDF files, do whatever you want. That's part of SolidSim as well. And it can lay the parts out flat with one more click, and you can see all the parts laid out flat. And these are the things that it ignored. Remember those little screws, right? These were less than that cube limit of 101 square millimeters. So they're red, they're ignored. Here is what the...
Estos parches en rojo no va a estar en la lista de corte porque normalmente cuando haces los cuadros es por antes. Okay, go ahead.
Here's what the feature recognition looks like. If I pick the part up and just move it, I'll put it over here. There's the results that we got. All right, we got circles on a layer with the depth. We got an outside on a layer. It's a polyline on a layer with the depth. And this one had a beveled edge. See that beveled edge? So look, there's a bevel piece right there too. Layer bevel.
Pero más o menos los partes tienen información que es requerido para programar la máquina.
That's what the feature recognition does. That's the part that takes and saves you the most amount of time. You know, it even extends edges. If you have dados, it'll extend those past the edge of the part. All right, so let's get to manufacturing that now. Let's get to cutting it. I'm going to exit out of SolidWorks. Now I could, like I said, right-click, cut with RouterSim, and it'll automatically start making the tool paths. But I'm going to start up our RouterSim automation, and I'm going to import that cut list. I want to manufacture the parts. It only really took one click so far. I did one click. It made me everything as individual files ready to go. Now we're going to process it and make 23 of those chairs. It'll look really great. I'm going to import the cut list. Here's an import from Excel. So we can import from any Excel file. And here is the spreadsheet that it just made a few minutes ago. I tell it what each column is. This is the name, the material, the quantity, and description. That's all I'm really interested in for RouterSim. If I have a saw, I would be importing those other dimensions.
Right.
Import. Here, okay, here's where it says, hey, I don't have the maple material. I can either make one, or I'll just put them back so they're all on that same material called generic 22, so they'll all nest
That's
same way.
that'll be fine.
All right, so they'll all nest on one sheet. Here's all the parts. And by the way, you can get a preview.
Los archivos de partes es como un minuto. Todo este plástico es explicando este país, lo importante es el dibujo de mueble hasta los dibujos de parte para maquinar es un minuto. Y ahorita van a hacer de código G. Estamos hablando, no todos son de router, pero estamos hablando de router en este momento.
The easiest way to change the quantity is to go over here in the job settings and change my part multiplier to 23. That's the easiest way. Part multiplier. So every one of these quantities will be times 23. All right? And then we can run the job. This will take about 4 or 5 minutes to process all those parts. And it's going to nest. We're going to get probably, I would think, 25 sheets of code. We're going to get 25 programs with that many parts on it.
Let me explain that. Ahorita, this is únicamente por este tipo de CIE cuando está tocando los partes. Él empezó de hacer los programas para 48 piezas. Y va a quedar 4 minutos más o menos. Y en 4 minutos, 23, ¿no? Para 23 CIEs. Para todos los partes diferentes, para 23 CIEs. So, en este momento está trabajando en el programa. La cosa es, estamos hablando sacando piezas de un hoja completa. Pero no tenemos que hacer todos así. Podemos hacer partes independientes. Pero no iría, obviamente, de más de repente. Hay muchas compañías que ensamblan madera sólida en hojas de 4x8. Y por eso es el finger joint line. Cuando haces finger joint y acanto, es muy rápido. Y en este caso, aquí lo ponemos muy bien, pero metes hoja de 4x8 y sacas bastante sólida. La otra forma es explicar el programa que tú quieres hacerlo en máquinas manuales. Bueno, en este caso para sacar otro tipo de información, que dibujos de partes, la lista de operaciones. Por eso, porque no tenemos 4 horas, vamos a ver este asiento hecho con tableros. En este, si por ejemplo tú quieres incluir algunas partes con triple de 19, unas partes con triple de 1 1/4 y unas partes con maple sólida, y es nada más in SolidWorks tienes que definir qué material es.
I want to point out, too, that this is making the individual programs for each part. So I'm going to get the single part programs. If you ever need to do a remake or just make one of these parts, the program will already be made so you can cut one of these parts by itself.
Okay,
Every one of these parts is making a single part program right now.
Que está haciendo programas por partes individuales. Y la ventaja de esta, porque va a ser guardado con este día, en el caso próximo semana o te falta 2 piezas, no tienes que hacerlo así completa. Porque hay programas que hacen los dibujos de partes por conversión. Tienes que hacer todos. O te falta una pieza. Es automático. So we're a few minutes into this conversion right now, right?
Right. Now, after the 34 individual programs are generated, the next step is it will start nesting with those large quantities. And you'll see that pop up in a few seconds. We're going to get, the nesting will show up. It's going to show us how many sheets we need, and it'll give us a cycle time for each sheet and for the entire job. So that should happen here in just a few seconds.
Very interesting.
In fact, I could see this here, what part it's working on, 32 right now.
Está trabajando en partes. El próximo paso es cuando todos los partes están dibujados con sus características de profundidad y de todo esto. El próximo paso es hacer el nesting. Optimización.
Here's the nesting process right now, where it's computing how to maximize the yield for that many parts onto the different materials.
Maximizar el rendimiento por 23 días con 38 partes diferentes. Y te va a decir después cuántos hojas necesitas, qué material. Estamos pensando en material genérico ahorita porque no está especificado, pero sí tienes, tú puedes especificar que tú quieres el material. Tableros
nosotros es diseñar el sillón y ponerle qué material necesitamos.
Exacto.
Y eso se mete al sistema, sin
Routersim.
se mete todo, porque necesitamos el dibujo y los materiales. Y la máquina del sistema lo que nos va a hacer es nos va a evolucionar todo, nos va a dar las listas de alimentación, nos va a decir cómo mandar a aportar a las máquinas.
El código G.
Con este agarramos un disco en USB, se va a la máquina, se conecta, tú pones la madera y empieza a cortar.
Sí.
¿Correcto?
Ahorita,
Y también te da los puestos y te da todo esto.
yeah. Everything. Bueno, what are we seeing here? We're seeing the nesting.
Those are the nested sheets. And there's, looks like about 26 nested sheets. And it's making the NC code now for each sheet.
Estos son los, these are 4x8 sheets.
Yes, they are.
Estos son hojas de 4x8, hay 26 requeridos por el proyecto. Es un material nada más, pero tú sabes. Ahorita está haciendo el código G.
¿Cuánto desperdicio maneja en este programa? Ahí él le pone qué desperdicio necesita o cómo lo maneja.
In a minute, he's asking the question that I mentioned earlier is, what kind of scrap are we going to have? What kind of scrap report?
Just that last sheet. There's about, it used about a third of that last sheet. See how there's some left over here? The sheet at the top has a little bit of leftover, and it's going to cut that off, and it could save that as a piece of scrap for next time.
Okay.
The other sheets, yeah, there'll be a report. The other sheets look like we have well over 90% yield.
Va a hacer un report. Él me dijo que parece que tenemos como 90% rendimiento en esas hojas. Y el único que no está pero va a imprimir una etiqueta y va a ponerlo en su inventario de hojas por el próximo proyecto. Primeramente va a sacar el servicio para antes los otros efectos. Okay, so ahorita he hecho los programas, eso es donde estamos invirtiendo, increíble tiempo. Y hay errores. Cuando tú, eso es importante, cuando tú haces un código que manualmente hay errores. Es muy fácil. Okay.
All right, so and keep in mind now, my hands are off the keyboard and mouse. This has been all automated since I typed in the number 23 for the quantity.
Sus manos no están haciendo nada. Después yo puse el número 23, cantidad 23. El programa está haciendo todo esto. So. All right.
Now we're going to get printouts of each one of those sheets. We're going to get a printout as a PDF file or whatever printer you want to send it to. It'll print to whatever printer you have. Then it's going to give us labels for every part. We're going to get a barcode label for each part with a picture of the part on there. We're going to get an accurate cycle time for each individual part, and then a cycle time for the whole sheet and the whole job.
Okay.
And we're going to get a yield report for each sheet. It's going to tell us exactly how much area was used and what kind of leftover. And then we're going to get a tooling report too that tells us how many inches each tool cut, or in this case, how many millimeters each tool cut. So you get a tool report too, so you can keep track of your tool life. So it's done making the NC code now. It's on that last sheet. It'll make a scrap cut too on that last sheet. So you wind up with a nice square piece.
But let me explain that. Después
Yes.
va el código de barra para cada pieza, o cada grupo de sus piezas. Cada código de barra va a tener un dibujo de parte para saber qué parte es. Va a hacer un reporte de rendimiento de manera, tiempo maquinando una pieza y tiempo en máquina para toda la producción. Vamos a verla. Pero tienes que poner unos en qué metros por minuto están trabajando. Por fin, tú vas a ver exactamente cuántos minutos tienes cada pieza. Y hay otras cosas. Okay, go ahead.
The process is complete. 9 minutes, 36 seconds later, 37 seconds, it's done.
9 minutes.
Here's all my results. The results pop open, and there's PDF files of each nest. Let me make that as big as I can so you can see them easily here.
Aquí hay dibujos cada hoja. Y recuerdas, pudimos ensamblar de manera sólida en tablas pequeñas. Ellos nada más tienen que meter nuestro mapa sólida es este tamaño. Está usando partes de este tamaño. No tienes que poner 4x8. Es importante. Eso es como puede trabajar como manera sólida.
¿Ahora cuánto se tardó en hacer ese programa?
9 minutos 37 segundos.
9 minutos en hacer el programa.
Ya. Y está listo por... Y ahorita este está conectado al router, bajarla y está en la máquina. So, realmente es por prototipo directamente, porque el dibujo es por basic, pero sí, por un sí es menos simple, porque tiene las calculaciones de bajarlo y hacer la fila. O los partes que pueden. Obviamente hay partes programáticas que tenemos que hacerlo de otra forma, pero tú puedes producir un 70% de sus piezas de otra forma, 80%. Es mejor, y unos partes muy raros a mano, por ejemplo. I'm just explaining that most of the parts can be made like this, but if we come up with some really strange part, we can't make it like this. So this is all.
You can manipulate the nest. You can move things around. You can erase parts. You can take them out of there, okay? Just take them out of the nest. If you don't want them, just take them out.
No, hay muchas cosas. No puedo decir todo. I mean, tú quieres decir que, bueno, por X razón yo no quiero hacer este parte, pero por
Kenny, let me say something here. Dan?
Yeah.
Kenny, pull a tool path out of one of those things while I'm talking, if you don't mind. Dan, this software will pay for itself in very short order. I'm talking weeks. And here's the reason why. The strategy to make a pattern, that is looking at it, it's called stay down technology. And what happens is the tool goes in once and comes out once. When you do that, okay, you get common line cutting and you reduce the amount of heat on that tool. And so you reduce the amount of time it takes to cut the pattern, because right now what they're doing is they're cutting one part at a time and lifting up and then plowing back in. We're going to cut it all with one sweep, and we're going to reduce the amount of time it takes, and we're going to reduce the amount of heat on that tool. So from a standpoint of saving tooling, it's significant. From a standpoint of saving time on the machine tool, it's significant. From a standpoint of saving yield on what you're getting, it's significant. I would say the payback on this is less than 2 months.
Yeah, let me explain that to them. Okay, hey, look. Pero tenemos gente que pueden programar las máquinas, pero no necesariamente son los mejores programadores del mundo. Hay muchas formas para programar.
Kenny, key in on the toolpath.
Yeah, let me do a number 8. This one looks good.
Tecnología es más para programar todo para la broca si baja y queda abajo, sigue moviendo por los mínimos subir y baja. ¿Cómo puedo explicarlo? Y está calculando por el tipo de broca y el diámetro y la velocidad, la temperatura de la broca, porque los brocas pierden su afilo mucho más rápido cuando están calientes. Y los brocas sí cuesta mucho. So, para tener mejor rendimiento en la línea de broca es una. Y también cuando está afilando brocas, está compensando por el reducido diámetro de la broca. So, no es programando, es programando. Hay programadores que la verdad son buenos y unos arriba y abajo.
I don't know about that crashed out. That was the simulation. I was trying to show you a simulation to show the tool removing the material, and I was playing with the speeds. But this will give you some idea of the tool stay down. See how it's staying down and cutting half of these pieces?
No está subiendo, no está subiendo. Y en el fin de día, I'm explaining it as you're speaking. Eso lo puedo coger por este hoja. El fin de día, tal vez piensas que esto no significa mucho, la verdad. Pero el fin de un torno sí significa la diferencia entre 500 lotes o 550. So, pero no es un detalle. Pues, con 8 horas de este detalle está hablando X es más por el mismo mano de obra. I'm just saying, you might think that, well, what does it matter the bit going up and down?
It matters a lot.
Over the course of the day, that could be 20 to 40 minutes of extra machining you can gain.
That's exactly what I was just saying. Over the course of a full shift, you're talking another 20, 30, 40 sheets or whatever it might be. It's not just a little detail, it's really important detail. Tool life and all that. Bueno, aquí es un código G. Está generada automáticamente, que es.
Here's the other results. You've got your labels.
Y no hay errores.
Barcode labels for each of the parts.
Y eso es donde tú puedes perder. Eso es donde tú puedes perder días, no minutos. Pero con errores tú puedes perder, tú sabes, es la cadena de errores. Eso es donde puedes perder días. Eso es proceso, no es su pequeño errores. I'm just explaining that when you automate programming, you're going to reduce errors. And errors can cost more than, and we all know this, we're smart guys here, but I'm just reiterating that point. Programming errors can cost more than anybody wants to think about. The one thing you sometimes don't even know they happened because the guys in the factory don't tell you. You know what I mean? That's a manager reality here. So we're just watching. You just printed some labels, correct?
Yeah, those are barcode labels. And here's the yields. What kind of yields you got?
This is important. Those
average 81.9% yield average. That based on the stock used, and then if you add up the part area, it's 84%.
Rendimiento es 84%. El 15% de desperdicio en este caso. No está mala. Es por el diámetro de broca, el polvo que está haciendo, los piecitos que salgan. It's un buen rendimiento.
And there's a summary report, the cycle time for each sheet, and the cycle time for the entire job.
Okay, let me explain. This is important. Cycle time per sheet es tiempo cada hoja, 7 minutos 40 estará, y tiempo de la máquina por todos los hojas para 23 días es 446 minutos. Obviamente manejando los tableros a la máquina, afuera de la máquina, eso es tiempo en la máquina. Eso es tiempo productivo. So I want to, can you leave that screen on just a second?
Yeah.
Is there any way to get a printout of that screen? Because that's what I'd like to show somebody who's not here.
Yes, I'll email those to you. I'll email the reports.
Moses stepped out and he walked right back in. But I want to explain.
Yeah, I can email the reports.
This is something he's very interested in. Okay.
Is Moses back in the room?
He's right here right now. He's off for like 3 minutes. Okay. Cycle time per sheet.
Oh, I'm sorry. You got your cycle time per sheet. Some of those sheets were supposed to run more than once. See, quantity 2, quantity 4. So sheet number 6, back in the drawing, here was, let's see, sheet number 6 is this one right here, and it says right on there, quantity 4.
Let Moses see the full spreadsheet again.
Estos datos con esos datos tú puedes programar, porque tú sabes para hacer 23 días requieres 446 minutos de por la máquina, pero obviamente tienes que calcular X porcentaje para traer material, sacar material.
446 minutos.
Yeah, 446 minutes para máquina. Let's see, how much time is that per chair? Eso, todos los piezas por una hoja. This is all the parts, 446. Divided by 23, es 19.3 minutos por día. 20 minutos por día, tiempo en la máquina. Este no es manejando el material. It's 20 minutes in the machine per chair, but I'm just explaining that doesn't include actually bringing and taking material away. Okay, keep going.
And then there's also the summary report, which gives you how many pieces were on each sheet. It did a total of 990 parts it nested.
Where does it show that? Just out of curiosity.
Right here, quantity. How many were on each sheet? Quantity per part sheet, right? These are how many are on each sheet, and then the total was 990.
Fabricamos 990 partes. So estos reportes son muy útiles para planear. Okay, go ahead.
And it also gives you the tooling summary, how many total millimeters each tool cut.
Y también, es otro factor que un buen supervisor de área de CNC tiene que saber es cuántos metros lineales la broca cortó, porque las brocas tienen una vida y después 10,000 metros cambia la broca. Para no, well, you know, you have to know after X number of meters of cutting to change the bit. I'm explaining in that. So we're all smiling here. So let's keep moving.
All right. So those were the summary, and then there's also a summary for each individual part as well. So we give you a summary for just this one part. It can give you a cycle time for one part. So you have your report for each individual part is in here as well. See, there's one of the parts right here.
Just más información.
And then the other data you get, other than that, you've got each of your individual drawings are in here. There's each of the individual parts with the toolpaths on them.
Y por fin tenemos dibujos de todos los partes.
And you could drag and drop those and make changes. I can drag it in here and put it right in this drawing and squeeze it into a, where's that top sheet? Had some room on the top sheet. Put it in there.
File de ensamble, por la gente de ensamble. Y por eso tú quieres imprimir un paquete de dibujos de partes, en X organización, subensamble, final ensamble, y ensamble. Por la gente de ensamble, ¿quién es su manual de ensamble? Ellos lo abren. Es muy importante. Es un ensamble, con dibujos de subensamble, los partes, el código, y por eso los supervisores no tienen ninguna excusa.
Es lo que se supone que hacemos acá. Entonces, tenemos todos los ensambles y subensambles para acá.
Eso es más automático. Y después, con la información del código de barra, podemos hacer un programa para ver en una pantalla dónde están las fábricas, los piezas. So anyways, this doesn't do anything. Does this do anything about inventory control or not? Like saying how many sheets we have in inventory?
Yeah, sure. Yes, it does. The material has a makes a scrap cut if there's so many inches left over. Okay, if there's 250 millimeters left over in X and Y, I'll make the scrap cut. Should I save the scrap? Should I use the scrap? And I can have it automatically decrease the quantity. So you tell it how many of those sheets you have. I have 500 of those sheets.
Mm-hmm.
And as they're used, it will start lowering that quantity until it's out of them.
Kenny, can you run a report on that to say you need to reorder if they have a order it, keep it at this level, reorder it at this level?
Hablando de control de inventario, y hay muchas cosas de control de inventario. Una es tienes 500 de tax que va a ponerte pieza y tú dices esto es scrap, van a hacer el código de barra, puedes guardarla y un programa futuro y puedes usar esto y considerar eso antes del toque de 4x8. Hay muchos reportes. Yo creo que ahorita no podemos ver todos. Y lo otro programa,
you could also put these alternate stock sizes in too, and that's by yield or by price. So you could put a price on for each sheet.
all
So
right.
it might come back and say use 2 sheets of 4x8, 1 sheet of 5x10, and 3
Okay.
sheets of 5x12.
Let me explain that. That's also a big deal. Alternate sizes. Vamos a hacer prioridad por mejor rendimiento o mejor precio. Tú tienes disponible 4x8, 5x5, 5x10, 5x12 precios por cada hoja y tú quieres mejor rendimiento. Tocas y estás diciendo tú quieres necesitas 4 piezas de 4x8, 100 piezas de 5x10, bla, 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 bla. Si tú puedes decidir quieres mejor rendimiento, en pocas palabras menos scrap, o mejor precio, porque tal vez seguramente 5x12 es más económico que 4x8. El costo por metro cuadrado. tú tienes que meter costos una vez. Okay, I explained that.
All right, so you have, also it can make the skeleton cut, so if there's any long scrap left over on the top, it'll chop it up for you using the router.
Okay.
Instead of whacking it against the dumpster, right?
Yeah. Y también, si tú quieres cortar el scrap, al que es más pequeña, puedes cortarlo. It's okay.
Here I'm making my own tool path, just a 2D. I made a 2D drawing. I dragged and dropped this part, then I just drew this myself as 2D. Right, so you can add your own two-dimensional drawings on there. You know, here's an ellipse, I can draw an elliptical shape. And we'll make a tool path on that one.
Guys asked me a question. Someone asked me again a little louder because I didn't hear him. Give me like 20 seconds. Bueno, this is open. Almost like that. Can we see the SolidWorks share quickly? I know you're burning up a lot of.
Yeah, sure, absolutely.
Kind of rip through that SolidWorks share a little bit.
Let me open it up. I'll start up the SolidWorks.
Boss here, shortly, so. But this is going quite well. So if we can kind of bang through that SolidWorks share without a ton of details, I think they see the immense flexibility.
There's the same. That's your part, right? It look familiar?
Yeah, vamos a ver rápido. Otro tipo de silla. Una sí que es completamente modelo sólida.
Here's the feature recognition button. I picked that.
Nuestro dibujo. Vamos a hacer un poco menos detalle pero this is el dibujo de ensamble. Just kind of bang through it however you want to.
All right, it's going to open up. It's going to do the feature recognition. Now this one has some things where we can maybe use an aggregate tool. Do you use aggregates to do machining on the side of the part?
He's asking, can we find out how much, no sé, porque eso tenemos que especificar nuestra máquina. But he's wondering if we can get an idea what the tool path time on this chair would be for one chair.
Well, this one, right, we wouldn't do the nesting. This is the one where we want to do single parts.
This, because este sí hemos hecho con hojas completas. Esto es parte por parte. En diferentes grupos. Y por eso tenemos que meter en el programa qué máquinas tenemos. Vamos a pasar esto de 5X. Vamos a hacer este en un trompo. Pero para hacer, vamos a ver que podemos hacer mucho, pero tenemos que hacer un poco más custom el programa por nuestra planta que más tenemos para ver sólida.
Here you can see it created some stuff on the side of the part here. It made this thing slot and front, so it's going. We could do horizontal machining with that. So this one is a little bit complex, right? These parts are a little bit complicated. And, you know, I don't know if we've got all the machining right. So you can edit these drawings if you need to. It did save me each of the individual parts. They're right here. And I'm going to import them.
3-axis router, right?
Yeah, with an aggregate, right? Would you use an aggregate on these?
Well, we would have to, yeah.
All right, so let's import that cut list.
Él está pensando hacerlo en un router de 3X con un aggregate. El aggregate es una cabeza con brocas que salga por el lado. ¿Sí tenemos aggregates? La broca que sale, tiene brocas que yo sepa así. Okay, so sí tenemos aggregates, instalarlo en la cabeza de shoulder, por ejemplo. Y la broca salga por acá para hacer fotos originales. él va a hacerla, sí, déjame seguramente que
I already had imported it one time, so
sí,
there it is.
pero los otros, requieren un poco más planeación. Él está pensando en un lado de 3X con una época. Pero tal vez para nosotros es más fácil que el 5X. Pero él no puede usar nuestro 5X porque los característicos no están. Una pregunta para cada...
So you see, with these parts, you can either do nesting or code single or both, nest and code single. On the other job, I did both, so I would have the single part program if needed. Now these parts, if you're going to cut on a saw and do hardwood not nested, you just check the box that says code as a single part.
Pero puedes programar fabricación en nesting o partes individuales.
Right, so we're going to do individual parts there. No nesting.
Okay?
And I already ran this once and I got results, and I have my individual part drawings in here. You know, some of them may have toolpaths that are more or less that are needed. So if you want to do horizontal work, I'll show you how you do horizontals. It's very easy to do. All right, let me close this one.
X. Pero sí puedes. Pero puedes hacer en 3X con un aggregate que es una broca que está horizontal. Él está pensando en aggregate para maquinar aquí y acá. ¿Cómo vamos a ver? On the shoulder.
Tengo que programar todas las cosas nuevas.
Para integrar nuestras máquinas en este.
No. Ahorita sale una silla nueva.
Ajá.
La podemos meter en el sistema. ¿Quién programa eso?
Nadie. Él hace el dibujo de silla. ¿Tú viste el dibujo de silla?
Sí.
El dibujo de silla que él ha hecho es cuando terminamos.
Se mete la máquina al sistema.
Yep.
Y ya todo explota el sistema.
Okay.
Say, Dan,
Este dibujo de silla. Now, he just asked me an interesting question, who does all the programming? And I said, really what it is we put the drawing in and the program does everything, right?
correct.
It does. You set up those machining knowledges, you make a toolpath, the toolpaths get generated automatically, and basically this is a toolpath to do machining on the side of the part right here. That's a toolpath that's going to lead in, cut that slot, then lead back out. Feed into the hole, cut it, feed back out. That's a horizontal machining with an aggregate right there. That's the tool.
An aggregate.
That's the tool to do that. And
Say,
you can do
Dan.
it on the top of the part the same way.
Dan,
You can do it on the
can
side, yeah.
you ask Moses, was he do they now do this chair in a nest?
No, because these are hardwood parts, Roger. These are
Parts, yeah. And we may glue up 4x8 sheets of 2-inch thick solid wood someday, but I have already explained to them that or not. Basically, el dibujo de nuestro sí que tuviste, ya lo he hecho, yo mío ellos, and this is cuando tú estás trading.
Por eso, tú se lo envías a ellos para tener la información, ¿no?
¿No?
¿Ellos qué hacen ahí?
Bueno, ellos venden el programa y cuando nosotros tenemos el programa aquí, él yeah, but you don't do anything. No haces nada. I mean, nada. Nada.
Pero venden el paquete
Yep.
y aparte cargan todos los datos.
Right. I'm saying I'm just explaining that with your program, once it's all set up with a knowledge base and so forth in the post processor, all we have to do is draw the chair.
And the feature recognition does the rest, and then the automation makes the toolpaths automatically.
Yep, and then all the reports we get.
You get reports, you get labels, you get the single part programs. There's a lot of data that comes with it. I'm going to email you those reports that we got.
It's not quite, you're just wondering if it's real that all we have to do is a chair drawing and the program prepares all our manufacturing data.
Well, let's say it right. You have to make the drawing in works perfectly. You have to make it so it's manufacturable, right? There's no cutting corners. You have to draw the model exactly as the parts are going to be created.
And we can do that. That's
right. It's a truth model. We call it a truth model. Some people model just so it looks like a pretty picture. And they don't take into account that those parts are going to be used for manufacturing. That's not going to fly, right? You know that.
No, we know. That we know.
Okay.
That we know, but I think you're just pretty amazed what you can do is what I'm saying. So
I mean, I've got a lot of examples just like that where, you know, it's hard to make a model that's not quite right, but it's not impossible. And I have an example. I love to show it because the parts look great, but when you zoom in, you can see some problems.
Con su dibujo, you're done. Hasta el código de barras hasta.
Con su dibujo y con información de materiales que necesitamos.
¿Pero quién quiere meter esto una vez? Es una vez. Y nada más cuando estás dibujando, eso es una vez. Y cuando estás dibujando, nada más está asignando X material cada pieza. This is just an example. This is just an example of yours.
Right. This is an example, but this part, as good as this looks, there's a couple areas where they took a shortcut just so it would look good, but then when we go to manufacture it, you'll see some errors that can pop up and you'll have to fix them. It's a restaurant booth. It's a little booth that's like an enclosed booth of some sort.
It's a booth for un restaurante.
It's right up your alley. You know, it's plywood type parts just like you make. And then here's a shaded view of it exploded.
Obviamente puedes hacerlo, pero que eres explicando con, well, I'm going to explain to them what you're telling me here. Que ella está explicando con esta. Tú haces un error en el dibujo, este error, la máquina puede reconocer X tipos de errores, pero si hay un error en el dibujo original, las partes van a salir mal. Pero no estamos todos.
All right. Here's a great example for you. See how this part looks? Here's the part if I pick it up and move it.
This is un ejemplo.
Look at that little sliver right there. See that?
Error en el dibujo.
They did not mean to make that, but this did the right thing. It protected that little sliver. It's going to pocket, and it's going to leave that little sliver standing up.
Can you show? Ese es un ejemplo de un error. Mira, el maquinado está dibujado con esta pequeña pieza allá, y ese es un error. So, tú tienes que pensar que es obvio, ¿verdad? Es cosa muy simple, obvio. Bueno, okay.
And I could fix it, you know, I could fix it myself by moving this line over here, move this one out here, right? And that's really what we needed, something like that, to pick that up, and that will clear the entire pocket out that way. But they modeled it like that, by accident left that little piece standing.
Error de modulación. Pero este,
and there's another part in here, this one up here, here it is. This one's got something else similar happening. This little thing right there, see that little booger right there? If I move that part, look at that. In the solid, they have that little thing sticking up. They didn't want that, okay, but I noticed it. So the toolpath is going to leave it standing up. See that? The toolpath actually went in and came back out. It's going to leave that standing there.
No, that was not. So if you can send me as many of those printed out reports for that share we did, that would be excellent for these
Absolutely.
guys to show us here. Well, one of these guys is the owner, but the other owners, and as many of those cool reports would be super. Maybe a sheet with barcodes, you know, and
Yeah.
I'll print it off, give it to the guys, and
I'll do
I
that.
think we're good. I think we're better than good. All right.
Thank
Okay,
you so
Dan.
much for taking a look.
I'm cutting off the recording now.